Okay, so just now I was saying in this energy changes reaction, we can use energy given out, energy being absorbed. We can use bond forming, bond breaking, and now we can also use the energy profile diagram or your energy level diagram. Okay, so activation energy is this minimum energy required by reactants for the reaction to occur. So all your reactants have some energy, whether they are solid, liquid, or gas. Okay, for reactions to occur, your particles have to knock against each other, and when they knock against each other, if they have enough energy, the bonds can break and they can reform. So this energy, when I say enough energy, what is it? I'm talking about the activation energy. So as long as these particles have energy higher than activation energy, reaction can take place. Okay, exothermic reaction, delta H is negative, right? Remember, if energy being absorbed, if it's a small number over minus a big number, this is absorbed, this is released. So release must be big, then my overall energy is released, which is delta H is a negative value. Okay, so absorb less energy than given out, like I tell you, less energy than given out. So products will have lower energy than reactants. Okay, so in a energy profile diagram for your exothermic reaction is this. Okay, when your products are giving out energy, right, you start your graph with two lines. Okay, important thing is why your product is lower, because these products, they are stable. Why are they stable? They give out this energy. So they give out this energy, their energy must definitely be lower, at a lower value. Okay, then write your reactants on the first line, your products on the second line, and then connect it with a curve. Okay, this is your energy profile diagram. Label your axis correctly. So kilojoules and progress of reaction or time. Okay, and then we have to label your activation energy. So, and activation energy is how much energy needed. Reactant, reach this amount, then reaction can take place. So this is your activation energy. It must be an upward arrow. Okay, label it activation energy, and then over here, it must be a delta H must be negative. Why? Because from a big number, I become a small number. This energy is being released out. It's at the lower end of your graph, like this part is at the lower end. So it is negative. Okay, this is my exothermic reaction graph. Okay, and then same thing, when you draw in the arrow to represent exothermic, it must be going downwards. Okay, endothermic reaction, energy is being absorbed. So endothermic reaction, my delta H is a positive value. So energy is being absorbed. Products or the reactants absorb in the energy to form this product. Products are of high energy level, so it's higher than the reactant. Okay, same thing, connect it with a curve. Write your reactants here, your products here. Label your activation energy from the reactants to the top of the hump. It's an outward arrow. Okay, and then label your delta H, right? From small number become big number is at the positive end. Delta H is positive. Okay, and this is endothermic. Okay, these are your energy profile diagram over here. These two diagrams are commonly tested. We have to know how to draw them.
The next part we are going to look at is the energy level diagram. Okay, the energy level diagram essentially is the same as your energy profile diagram. Okay, so same thing, this is my exothermic reaction. Right, exo, the energy is given out, so my products give out the energy, it has low energy level, and my reactants will still have high energy level, which is the same. The difference is, right, there is no harm over here. I don't have to draw the curve. Okay, as a result, without the curve, there will be no activation energy. Okay, so same thing, write my reactants here, my products here, right? And same thing over on this part. the delta H is negative value because it's at the lower end. Okay, and then the delta H is from reactants to product, draw a downward arrow, and it is a negative value. In my endothermic reaction, energy is being absorbed, so the products will have high energy level, higher than the reactants. Okay, so when they absorb in the energy, my enthalpy change is an upward arrow and is positive. So it's on this positive part, not on the below, it's on top. Okay, and there is no curve. As a result, there's no curve, there is no activation energy. Otherwise, everything else is the same. The energy level diagram is the same as my energy profile diagram.